Good day, friends, and you are again welcome to another WASE online experience. My name is Philip, and I'll be your instructor for today. But before we start our activity for the day, I'll need you to subscribe to our channel if you've not already done that. Remember, once new videos are created, you'll be sent an alert if you have subscribed to this channel. To be able to do this, you simply need to go below the video and tap the subscribe button. Alright, thank you very much for doing this for us. Let's look at our activity for the day. Today, we'll be looking at the part 4 of algebraic expressions, and under this part we'll be looking at binomial expressions. In part 1 of this topic, whilst we were looking at introduction to algebraic expressions, we came across binomial expressions. And I believe you remember what we said about binomial expressions. Well, if you've forgotten, then I would remind you. We said that a binomial expression is an algebraic expression with two terms. The prefix bi means two. Let's look at some examples of binomial expressions. So first, we have the algebraic expression 5x plus 4. We also have the algebraic expression negative 6y minus 4x. Then our last example, we have 2y minus 4. All of these expressions are binomial expressions because they have two terms. In our first example, the algebraic expression 5x plus 4 has its first term to be 5x and the second term to be positive 4. So you see, we have two terms in this algebraic expression. That makes it a binomial expression. With our second example, the two terms are negative 6y and negative 4x. So binomial expression. Again, with our final example, the two terms are 2y and the next will be negative 4. That makes it a binomial expression. In our next slide, we are going to look at how we can multiply two binomial expressions. So let's look at how we can multiply two binomial expressions. For example 1, we'll be multiplying the binomial expression a plus 2 all into bracket by the binomial expression a minus 3 all into bracket. When you are given something like this, take the first binomial expression. In this case, the first binomial expression is a plus 2. You would then take the first term of this first binomial expression. In this case, the first term of this binomial expression is a. So let's write that first. We would multiply this a by the whole of the second binomial expression. The second binomial expression is a minus 3 all into brackets, so the a will be multiplied by the a minus 3 all into bracket. Let's quickly do that. We would then write the second term of the first binomial expression. As we already know, the first binomial expression is a plus 2 and its second term is plus 2, so we would write plus 2. We would again repeat the second binomial expression. The expression a minus 3 into bracket, so we would multiply it again with this plus 2. So let's quickly do that. At this point, we have a new expression which is equals to a all into bracket a minus 3 bracket closed, then plus 2, then bracket a minus 3 again bracket closed. The next step is to expand the expression by removing the bracket. For us to do this, we would multiply the a outside of the bracket to the a inside of the bracket, then afterwards we multiply it by the negative 3. When we are done, we'll take the positive 2 outside of the bracket, multiplied by the a inside of the bracket, then we'd also multiply it by the negative 3 inside of the bracket. So that's what we are going to do. When we do this, we would get, so what happened was that the a multiplied the a and we got a square. Again the a multiplied the negative 3, we got negative 3a. Then we had positive 2 multiplied a, that gave us 2a positive. Then the positive 2 again multiplied the negative 3, that gave us negative 6. As simple as that. Next, we are going to group all the like terms in this expression and add them together. When you look at this expression carefully, you realize that the negative 3a plus the 2a are like terms. When we add 2a to the negative 3a, we would get negative a. So what this means is that we would get the expression a square negative a, then our minus 6. Let's look at example 2. In example 2, we have the binomial expression 3x minus y all into brackets multiplied by the binomial expression 2x minus y all in brackets. So as usual, we would have to take the first term of the first binomial expression. The first binomial expression is 3x minus y. Its first term is 3x. So let's write that down. We would multiply this 3x by the whole of the second binomial expression, which is 2x minus y all in brackets. Let's do that. We would then write the second term of the first expression. The second term of the first binomial expression is negative y, so we would write negative y. Then we would write the whole of the second binomial expression, 2x minus y all in brackets. So let's quickly do that. At this point, we have a new expression, that is 3x all into bracket 2x minus y bracket closed minus y. Then we have bracket 2x minus y bracket closed. We will now expand the expression by removing brackets. So first, the 3x would multiply the 2x. That would give us 6x squared. The 3x again would multiply the negative y. That would give us negative 3xy. Then our negative y would multiply the 2x, and that would give us negative 2xy. Again, the negative y would multiply the negative y within the bracket, and that would give us positive y squared. At this point, we'll be grouping like terms. When you look at the expression carefully, you would realize that negative 3xy minus 2xy will be our like terms. Negative 3xy minus 2xy would give us negative 5xy. What this means is that our expression will now become 6x squared minus or negative 5xy plus y squared. So that would be our final answer. Let's look at example 3. For example 3, we have the binomial expression 4m plus 3x bracket multiplied by the binomial expression 2m minus 3x bracket closed. Let's do this together. So as usual, we'll multiply our 4m by the whole of the 2m minus 3x. Then we'll also multiply our 3x by the whole of the 2m minus 3x. So first, the 4m would multiply the 2m. That would give us 8m squared. It would again multiply the negative 3x, and that would give us negative 12mx. Then the positive 3x would multiply first the 2m. That would give us 6mx. Again, the positive 3x would multiply the negative 3x, and that would give us negative 9x squared. At this point, we would group like terms. The like terms are negative 12mx plus 6mx. Negative 12mx plus 6mx would give us negative 6mx. Therefore, we would get the new expression 8m squared minus or negative 6mx, then minus our 9x squared. So that would be our final answer. Let's look at the example 4. And in this example 4, we have the binomial expression 3x minus 2 bracket multiplied by the binomial expression 2y plus 4 all into brackets. So as usual, we would multiply 3x by the whole of the binomial expression 2y plus 4. Then we would also multiply negative 2 by the whole of the binomial expression 2y plus 4. When 3x multiplies 2y, you would get 6xy. When 3x multiplies 4, you would get 12x. Then here, when negative 2 multiplies 2y, you get negative 4y. And again, when negative 2 multiplies 4, you get negative 8. In this expression, 6xy plus 12x minus 4y minus 8, it looks like we do not have like terms in here, so we would have to leave that as our final answer. So that's the final answer. At this point, we'll be looking at a few tricks. Now, we can have the situation where you would have a binomial expression multiplying itself. For example, we can have the binomial expression a minus b multiplying the same binomial expression a minus b. These two binomial expressions can be multiplied using the method we initially used, by just multiplying the first term of the first binomial expression to the whole of the second binomial expression, then the second term of the first binomial expression to the whole of the second binomial expression. At this point, that is what we know. However, in mathematics, whenever an item multiplies itself, it forms a squared number or a squared item. This is also referred to as a perfect square. So, for example, when 2 multiplies itself, it forms the number 4. Remember, 2 times 2 is 4. 4 is a perfect square because we obtain 4 by multiplying the same numbers together, 2 and 2. So 4 is a perfect square. The same way, when the binomial expression a minus b multiplies itself, it also forms a perfect square, which will be a minus b all squared. Now, when a binomial expression is given to you, and that binomial expression is a perfect square, in this case we have the binomial expression a minus b all into bracket square. It is a perfect square, and you are asked to expand it or solve it. You are going to use this trick. So first, you take the square of the first term of this binomial expression. In this case, the first term of the binomial expression is a. So the square of a would be a square. We would then multiply the first term, the second term, and the square together. So the first term is a, the second term is negative b, and the square is the number 2. So a times negative b times the number 2 we multiply together. When we do this, we would get negative 2ab. We would finally take the square of the second term. In this case, the second term is negative b. The square of negative b is positive b squared. Let's look at another example of a perfect square. In this example, we have the binomial expression a plus b multiplied by itself a plus b. We want to expand this expression. How do we do this? Let's write this expression first as a perfect square. When we do this, we would get a plus b all into bracket square. Now let's use our trick to expand this perfect square. So first, you take the square of the first term of this binomial expression. In this case, the first term of the binomial expression is a. So the square of a would be a squared. So at this point, we would multiply the first term, the second term, and the square together. The first term is positive a. The second term is positive b. So multiply these two together and multiply them to the squared number. When we do this, we would get positive 2ab. Finally, we would take the square of the second term. The second term is positive b. The square of positive b will be positive b squared. So like I've explained, if you are given a binomial expression which is a perfect square, you do not need to follow through the normal process to get it expanded. All you need to do is to use this trick and you'll be able to expand it and get the same correct answer. Let's look at the next item. In this trick, let's take the binomial expression a minus b. Let's multiply it by the binomial expression a plus b. Let's try and expand this expression, the a minus b all into brackets multiplied by the a plus b also all into brackets. To do this, we'll first take the first term of the first binomial expression, and it is a. So we'll take the a, then we'll multiply it by the whole of the second binomial expression, which is a plus b all into brackets. We will then take the second term of the first binomial expression and multiply it again by the whole of the second binomial expression. So we'll first take negative b and multiply it by all into bracket a plus b, bracket closed. The a times a would give us a square. The a times b would give us ab. Let's move to the second part. The negative b times a would give us negative ab, and the negative b times b would give us negative b squared. The like terms in this expression are positive ab minus ab. When you solve for this, the minus ab would cancel out the positive ab, and that would give us the final answer, a square minus b square. In this final answer, you would realize that you have a squared item being subtracted from another squared item. Another word for subtraction is difference. So because you have one squared item being subtracted from another squared item, you can refer to this expression as difference of two squares. I need to make you understand that it's very important for you to be able to identify difference of two squares problems whenever algebraic expressions are given to you. Knowing how to identify them in algebraic expressions makes it easier for you to solve problems that contain them. So an expression like this, x squared minus y squared, is an example of the difference of two squares. So when you are given something like this, right away you know that x squared minus y squared is the same as x minus y all into bracket multiplied by x plus y all into bracket. This also means that when you have all into bracket mb bracket close all squared minus all into bracket hk bracket close all squared, we can also do the same thing with this expression. When we do this, we would get mb minus hk all into bracket, then that multiplied by mb plus hk all into bracket. As simple as that. Let's try this example. In this example, we have been given the perfect square a minus b all into bracket square plus another perfect square a plus b all into bracket square. We already know the trick we can use to expand the perfect square a minus b all into bracket square. So let's quickly do this first. So a minus b all into bracket square would give us, first let's take the a squared, then we take our minus sign, then we bring our 2 multiply by our a and the b, then we take plus, then we take our b, then we square it. So that's how this perfect square a minus b square can be expanded. Let's now write our plus sign. We are at this point left with the second perfect square a plus b all into bracket square, and we will need to expand that as well. So a plus b all squared, when it's being expanded, would give us a squared, then we bring our plus sign, then we have 2 times the a times the b, then again we bring our plus sign, then we take our b, then we square the b. So that's how we expand the a plus b all into bracket square. At this point, we would be grouping our like terms. When we do this, we would get the new expression a square plus a square, then minus 2ab, then plus 2ab, then again plus b square, plus again b square. So that's how we would group our like terms. So at this point, we'll be adding our like terms. So first we'll take the like terms a square plus a square. That would give us 2a squared. So let's write 2a squared. Let's take our second set of like terms, and that is negative 2ab plus 2ab. Negative 2ab plus 2ab would cancel out each other, so that whole expression will be 0. So let's close it, we'll cover it. Let's take our last set of like terms, and these are positive b squared plus another b squared. 2b squares being added together and all of them being positive would give us positive 2b squared. So let's write positive 2b squared. So our final answer to this example is 2a squared plus 2b squared. As simple as that. Let's look at another example. In this example, we have been given the binomial expression 2c minus 3 all into bracket times 5c plus 2 all into bracket, then minus 3c plus y all into bracket times 2 plus y all into bracket. So when you are given something like this, it is advisable that you solve them in bits and you join them together. So we are going to solve the first part of the question, that is the first two binomial expressions being multiplied together. So let's quickly do that. So in multiplying 2c minus 3 all into bracket to the 5c plus 2 all into bracket, first the 2c would multiply the whole of the 5c plus 2 all into bracket, then the negative 3 would also do same. It would multiply the 5c plus 2 all into bracket. Let's now bring our negative sign. Then the second part of our expression, that is 3c plus y multiplied by the whole of 2 plus y. So when you do this, you would get first the 3c would multiply the 2 plus y all into brackets, then the y would also multiply all of the 2 plus y. Now let's go back to the first part of our expression. So 2c times 5c would give us 10c squared. Again, the 2c times the 2 would give us 4c. Then negative 3 times 5c would give us 15c. Again, the negative 3 times the 2 would give us negative 6. Let's repeat the minus sign. At this point, we'll be looking at the second part of our expression. So 3c times 2 would give us 6c. Then 3c again times y would give us 3yc. We are going to the y. Y times 2 would give us 2y. Then y times y would give us y squared. Now you realize that we solved the various parts of the algebraic expression separately. The first part we solved it separately in one blue bracket, and the second part we also solved separately in another blue bracket. So we have to remove them. But you need to remember that we don't just remove them. We need to remove them by taking into consideration the operation signs in front of them. For the first part, the operation sign in front of it is positive. Remember, when you do not see any operation sign, what it means is that a sign is positive. So it is the positive operation sign. When the operation sign is positive, you can just remove the brackets. So let's quickly just remove the bracket. When we do this, we would get the same item, the same expression, 10c squared plus 4c minus 15c minus 6. Nothing had changed. The second part of the expression has the negative sign in front of the blue bracket. So that's where the problem would be. We would have to remove the bracket, taking into consideration that negative sign. Remember, that negative sign would multiply each of the terms in that blue bracket. The negative sign would multiply the 6c. That would give us negative 6c. It would again multiply the positive 3cy, and that would give us negative 3cy. Then it would multiply the positive 2y. That would give us negative 2y. Then finally it would multiply the positive y squared, and that would give us negative y squared. At this point, we would group like terms, and when we do that, we would get 10c squared plus 4c minus 15c, then minus 6c minus 3cy minus 2y minus y squared, then minus 6. The like terms in this expression are positive 4c minus 15c, then minus 6c. Positive 4c minus 15c minus 6c would give us minus 17c. So let's write our 10c squared, the first term. Let's write it down. We would write the remaining of the terms down, and these are negative 3cy, negative 2y, negative y squared, negative 6. We no more have like terms in this expression, so that will be our final answer. 10c squared minus 17c minus 3cy minus 2y minus y squared minus 6. Let's look at the third example. In this example, we have been given the binomial expression 2a minus 3 all into bracket multiplied by 3a plus 2 all into bracket, then plus the binomial expression 3a plus b all into bracket multiplied by the binomial expression 2a plus b all into bracket. So like we've already said, we'll solve this algebraic expression in bits. So first we'll look at the first part of this algebraic expression, which is 2a minus 3 all into bracket multiplied by 3a plus 2 all into bracket. This would give us the 2a multiplied by the whole of 3a plus 2 all into bracket, then the negative 3 would also multiply the whole of the 3a plus 2, also all in one bracket. Let's now write our plus sign. We will then look at the second part of this algebraic expression, which is 3a plus b all into bracket multiplied by 2a plus b. This would give us the 3a multiplied to the whole of the 2a plus b, then the plus b multiplied to the whole of the 2a plus b again. Let's come back to the first part of our algebraic expression. So the 2a times 3a would give us 6a squared. Then the 2a times 2 would give us 4a. Let's go to the negative 3. It would multiply the 3a, and that would give us negative 9a. Then the negative 3 again would multiply 2, and that would give us negative 6. Let's write our plus sign. Now let's go to the second part of our expression. So here the 3a would first multiply the 2a, that would give us 6a squared. It would again multiply positive b, and that would give us 3ab. Let's take the positive b. It would first multiply the 2a, that would give us positive 2ab. Then it would multiply the positive b, and that would give us positive b squared. At this point, we would have to remove our blue brackets. Remember, we solved individual algebraic expressions separately, so we would have to remove the bracket in order to merge them together. So that's what we are going to do. And like we've already said, we do not just remove them. It's easier for us to remove them if they have positive signs in front of their brackets, that you just remove them. But where you have negative signs in front of them, you do not just remove them. You consider the negative sign as well. But in this case, the blue brackets all have positive signs in front of them. So it's easier for us to simply remove the bracket. So let's quickly remove the bracket. For the first item, when we remove the bracket, we would get 6a squared plus 4a minus 9a minus 6. And we got the same thing because the sign in front of the bracket is positive. Let's write our plus sign. The sign in front of the second part of the algebraic expression is also positive. So we would end up writing the same expression, which is 6a squared plus 3ab plus 2ab plus b squared. So at this point, we would group like terms. And when we do that, we would get 6a squared plus 6a squared again plus 4a minus 9a plus 3ab plus 2ab minus b squared minus 6. The first group of like terms are 6a squared plus another 6a squared. The two joined together would give 12a squared. The second group of like terms are positive 4a minus 9a. When we join the two together, we would get negative 5a. The third group of like terms are positive 3ab plus 2ab. When you join them together, we would get 5ab. Now let's bring the remaining terms of the expression. Negative b squared, negative 6. Since we do not have any more like terms, this expression would remain our final answer. That is 12a squared minus 5a plus 5ab minus b squared minus 6. I hope you found that interesting. Well, friends, at this point we'll be bringing the part 4 of algebraic expression to an end. In our next meeting, we'll be looking at the part 5 of this topic. And in the part 5 of this topic, we'll be looking at factorization of algebraic expressions. Thanks very much for staying with us, and please subscribe for this channel if you have already not done that. We need your subscription for the continuation of this program. Also, once you subscribe and we make or come up with new videos, we will get you alerted. Thank you. Stay safe until we meet again in the next video.